Hi everyone, we are going to start day 3 reviewing for our second semester, chapters 7, 8, 10, and 9. So in 7.1, we are asked to solve the system by graphing. We have two equations. We want to find the point that makes these both true, the one point that makes these lines both true. So if I need to graph, I'm going to list, and it's in y equals mx plus b form, I'm going to list my m and my b. For my first equation, my slope is negative 1/2. For my first equation, the y-intercept is negative 3. My second equation is also in y equals mx plus b, so I'm going to list my m is 3/1, and my b is 4. Remember, we list our slope as a fraction so that we know what we're rising and what we're running. What we're rising and what we're running for each of the lines. My first equation tells me to start at negative 3 on the y-axis. It's the y-intercept. So negative 1, negative 2, negative 3, put a point. And the slope tells me I need to go rise, down 1, run, right 2. So down 1 and right 2. Down 1 and right 2. Down 1 and right 2. Up 1 and left 2 also works. Up 1 and left 2 also works. Up 1 and left 2. Now we're looking for where these lines intersect, so it's important that you graph accurately and that you put enough points on the graph to actually see where these two lines meet and touch. My second line, my y-intercept, says to start at 4. And my slope tells me to go up 3 and right 1, which means I'm going to go back down 3 and left 1 because I'm going farther away from my points if I go the other direction. Down 3 and left 1. You can see that that's where they intersect. Down 3 and left 1, and then I'm going to connect those points to make my other line, and then it's important that I list out and write out the ordered pair answer, which is negative 2, negative 2. That's where those lines meet. This point would make this equation true and this equation true. Number 4, we're solving the system of inequalities, similar to the system of equations. But because I have inequalities, I'm going to be thinking about dotted and solid and shading. Unfortunately, there's more work to do in 4 because, as you can see, the y is not alone. So first, I like to graph my lines in y equals mx plus b. Subtracting over the 2x, I get y is less than negative 2x minus 3. Therefore, I can say my slope is negative 2/1. My b is negative 3. I can say dotted and below for that one. My second inequality here, I'm going to subtract over the x. I get 3y is greater than or equal to negative x plus 6. I'm going to divide all of these by 3 to get y is greater than or equal to negative 1/3 x plus 2. Therefore, I can list my slope as negative 1/3 and my b is 2. Here I know I need to use a solid line and I need to shade above. So, graphing that first line, starting at negative 3. Oops, lost half the paper. Give me just a sec to do this. Starting at negative 3. And then moving down 2 and right 1. Down 2, right 1. Up 2 and left 1. Up 2 and left 1, up 2 and left 1. Dotted when I connect these. Yikes, sorry guys. Dotted when I connect, and I need to shade below. So I know I'm going to shade somewhere here, but I'm going to wait until I add my next line in. That next line says to start at 2 on the y-axis. My slope says down 1 and right 3. Or up 1 and left 3. Up 1 and left 3. So when I connect these, I need solid line and I needed to be below this line and above this line, which means I'm shading right in this section up here. Number 6 is about exponential growth and decay. Remember, the growth model said y equals c times the quantity of 1 plus your rate raised to the t. And the decay model had a subtraction. So when we look at number 6 on the worksheet, it says you deposit $125 in an account that pays 8% interest compounded yearly. Find the balance after 3 years. So I'm going to write y equals c equals r equals and t equals off to the side. When I read that and it says $125 has been deposited, I know that that's my initial amount, what I went to the bank with. So that's the C value. We know that the rate is always the percent in the problem, and in this problem we have 8%. Now we have to convert that to a decimal. We have to move 2 places because we know mathematically we can only use decimals within the problem. And then it said find the balance after 3 years. So my time is going to be 3. I need to find y when I have C, R, and T. So I write the formula. It's a growth. I forgot to stress the growth piece. It's a growth because you're going to the bank, you're giving the bank money, and then you're earning interest on that money. So you're going to make money from the bank if you leave your money there. So 125 sub in, keep the parentheses, keep the 1, keep the plus, sub in the 0.08, and sub in the exponent of 3. Now remember, we just go to our calculator and we plug this in all in one step. So I'm going to go ahead and do 125, open parenthesis, 1 plus 0.08, close parenthesis, raised to the power of 3. And see that I'm going to have $157.46. $157.46. $157.46. Number 8 says to factor completely, looking for a GCF here. 9 goes into 18, and 9, 18, 27. So 9 doesn't go into 21, but let's think about another number that goes into 9 evenly, which is 3. 3 goes into 9 evenly. I know 3 goes into 18 evenly, and I know 3 goes into 21. So this one has a GCF of 3. So I'm dividing out that 3 first. When I do that, I get 6x squared plus 7x minus 3. Keeping the 3 outside, my next step is to, and my next goal is to get a box to work for what I have there. What I have in the quantity is what I should say, not just there. 6x squared minus 3, setting up the box. I'm going to try 3x and 2x. And then I'm going to try 3 and 1. I want positive 7s. I'm going to put my negative with the 1. My check on my diagonals is going to give me 9x minus 2x. Multiply this diagonal to get 9. Multiply that to get a negative 2. 9 minus 2, 7x. That box works. My factors in the box says 3x minus 1 and 2x plus 3. I have factored completely. That's my final answer. And number 10, I'm going to go ahead and solve this quadratic using the quadratic formula. But remember, to use the quadratic formula to list out your A, B, and C, you have to make sure your equation is equal to 0. So I'm going to start by subtracting over the 7. I get 12x squared plus 10x minus 16 equals 0. Yes, there's a GCF here, but that's okay. I don't need to focus on GCF when using quadratic formula. So I'm just going to say my A is 12, my B is 10, and my C is negative 16. You could, to make the number smaller if you wanted, we would still get to the same answer. So, singing the song one last time for you guys. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. And then I just start to plug in. So I'm going to take and write x equals negative 10 plus or minus the square root of 10 squared minus 4 times 12 times a negative 16 all over 2 times a. 2 times 12, I'm just going to go ahead and right away say 24. So I get negative 10 plus or minus the square root. 10 squared is 100. On my calculator, just to save us some time, I'm going to go ahead and multiply negative 4 times 12 times negative 16, and I get a positive 768. Positive 768 over 24. So 768 plus 100 is going to give me 868. I'm going to move up here. X equals negative 10 plus or minus the square root of 868 over 24. I'm going to check to see if 868 is perfect. Second square root, 868. It's not perfect, so I'd have to find the perfect that goes into that. And then I'll be reducing on the outside of that. So let's see. I'm going to go ahead and see if I can divide that. Divide it by 4 and use 4 and 217. Oops, sorry. So I'm going to do 4 times 217 gives me 868 over 24. 4 is perfect. It comes out. So I have negative 10 plus or minus 2 root 217 over 24. And then these three numbers on the outside can be reduced. So my final answer is going to be negative 5 plus or minus the square root of 217 over 12. This is a 17. 217 over 12. Have a great day, everyone.